All right, let's take a look at what the graphs of the sine function and the cosine function look like. So you guys are familiar with sine and cosine from SOHCAHTOA, but they're way more than just a way to solve right triangles. Turns out y equals sine of x is its very own function. It is one of the 6 trig functions that we talk about. So we're only going to do 2 of those 6, sine and cosine. The graph of y equals sine of x looks like a squiggle that goes forever and ever up and down in both directions. Okay, goes as high as 1 and goes as low as -1. This squiggle is a periodic function, and what that means is that one shape or one squiggle repeats itself over and over and over again. If I were to draw this over and over and over again, you would see this same shape that I've highlighted in yellow picked up and moved over and over and over, repeating. Okay, we call that one unique squiggle, or what I've highlighted in yellow, one period. Okay, and we measure the period by measuring the length along the x-axis that it takes to complete one squiggle. Okay, so we say that the period for sine, since we start at 0 and end at 2 pi, is 2 pi. Okay, we can also talk about amplitude when we talk about a periodic function, and the amplitude is the biggest distance from the x-axis that our curve squiggles up and down. Okay, and so amplitude, since amplitude is distance, amplitude is always positive. So the amplitude of a sine curve, you can see, is 1, because we squiggle up 1 and down 1 from the x-axis over and over and over again. Never gets shorter, never gets taller. Okay, in this box over here on the left, this kind of yellowish beigey box, you can see all sorts of other properties of the sine function, which I would encourage you to read and look at. Pause the video, read what they say, make sure that you understand that. Okay, the cosine function is very, very similar to the sine function. In fact, the shape is exactly the same, it's just shifted. So if I highlight that yellow portion of the cosine function, it kind of looks like the exact same shape as sine, and it is, but the cosine function has been shifted over. So notice that sine goes through the origin, cosine does not. They are both periodic functions, so they both are squiggles that repeat over and over and over again. Okay, the cosine function has a period of goes from 0 to 2 pi, so has a period of 2 pi, just like the sine curve does. Has exactly the same amplitude because it squiggles up to 1 and down to -1. Still goes forever and ever in both directions. Still periodic because this same bowl-ish kind of shape repeats over and over and over again, forever and ever to the right and to the left. Just like any other function, we can do transformations with sine and cosine, which is what we're going to talk about. We are only going to, in this video, transform the period and the amplitude. Remember, amplitude is the greatest distance from the x-axis that your curve squiggles, and it's always positive. And period is the length along the x-axis that it takes to complete one squiggle. So those two transformations would be a vertical stretch and shrink, that would affect the amplitude, and a horizontal stretch and shrink, which would affect the period. If you're looking at an equation, like I've got in that box there, and you want to figure out the amplitude and the period, it's very, very easy. Amplitude is the absolute value of the number in front of the whole entire equation, and the period is 2 pi divided by the number in front of x. So let's look at this first example. 2 sine of 3x. The amplitude is going to be the absolute value of the number in front, which would be 2. And the period would be 2 pi divided by the number in front of x, which is 3. So if I'm going to draw this graph, it's a sine graph, so I want to go through the origin. Okay, I want to end at 2 pi over 3, which is this dot right here. Okay, sine, if we look back at our original, notice we start at the origin, one squiggle ends at whatever the period is. You cross the x-axis halfway between the beginning and the end of the squiggle. You have your maximum value, right, which is your amplitude, halfway between those two x-intercepts, and your minimum value halfway between the last two x-intercepts. And there goes the bell. So let's see. I want to have an x-intercept halfway between the beginning and the end. I want to have my maximum, which is 2, halfway between the first two x-intercepts, and my minimum halfway between the last two x-intercepts. If you can draw those 5 dots, then you just have to squiggle them together to complete the graph. Okay, and I'm only going to ask you to draw one squiggle. Now, in actuality, this would go on forever and ever, wouldn't it? All the way down to -2 though, right? This would squiggle forever and ever and keep going forever and ever. It's kind of hard to look at that, and it's kind of tough to tell the amplitude and the period. So you need to understand that it goes on forever and ever. I'm only going to ask you to graph one squiggle or one period. Okay? All right, let's look at this next one. Y equals negative sine of 2x. So the amplitude here would be the absolute value of the number in front, which would be the absolute value of -1, which is +1. And the period would be 2 pi divided by 2, which is pi. Okay, so we're going to draw a sine curve that starts at 0, ends at pi, has an x-intercept halfway between. That's always the case. Okay, we want to go up to 1 and down to -1. So let me label my y-axis here. Okay, everything's wonderful, except this minus sign. What in the world does that do? The minus sign in front of the whole thing, that is a flip over the x-axis. Okay, so be careful. You got to understand that flip, although it doesn't affect the amplitude because amplitude is distance and always positive, the minus sign in front will make your whole curve flip over the x-axis, which means that instead of going up to 1, we first go down to -1, then we go up to 1. So our curve is the mirror image over the x-axis. Okay? All right, let's look at this one. Y equals 2 cosine of 2x. Okay? Which is lovely. All the same exact rules apply when we're transforming a cosine graph as when we are transforming a sine graph. So the amplitude is 2, and the period would be 2 pi divided by 2, which is pi. Okay, so we know that we're going to go up to 2 and down to -2. So we're going to go up to 2 and down to -2. Since this is a cosine graph, we are going to not go through the origin. We are going to start at our maximum value. So look back here at our cosine graph. We start at the amplitude. We squiggle down and back up like a bowl. Okay, so we're going to follow that same shape. We want to end at pi. Halfway between those two maximums is where we have our minimum. And then again, halfway between the max and min, we have our two x-intercepts. Now don't connect those graphs, or excuse me, those 5 points in a V, right? That is not a cosine graph. That is not anything nice and smooth and squiggly. Okay, so when you connect these, make it look bowl-shaped, make it look curvy and squiggly. Okay? All right, let's look at another one. We've got, there goes the bell, -4 cosine of 2/3 x. So our amplitude is the absolute value of -4, which is +4. I'm going to make a note here to flip because I don't want to forget later. Okay, the period is 2 pi divided by 2/3. Well, that's a little tricky, isn't it? We got to keep change flip. So we got 2 pi times 3/2. Okay, which I can cancel my 2's if I want, and that gives me 3 pi. Okay, so it looks like the graph I've given you is not quite big enough, is it? Let's, just for funsies here, let's mark off all of these, and let's make that 3 pi. We'll just change it as we want, okay? Excuse me. So we have a cosine graph. Goes up to 4 and down to -4 because that's the amplitude. Okay, cosine starts at its maximum, but don't forget this one's been flipped. So we're going to start down here at -4. We're going to end at 3 pi. Okay, halfway between our two minimums is where we have our maximum. And halfway between the maximum and the minimum is where we have our x-intercepts. And I'm going to draw this upside down cosine curve, okay, because this is cosine with a flip. Okay, goes up to 4 and down to -4, has a period of 3 pi. Okay, This is probably a good time in the video for you to pause and try some of these next ones on your own and see how you're doing and what you're doing and if it all makes sense to you. Okay, so I'm going to give you a minute to pause. It's so much better for you to try these on your own before you keep going and just watch me do them, okay? So go ahead and pause and then come back and check your answers, okay? All right, so hopefully I'm coming back after you've tried this one on your own. You might have noticed that I didn't mark the X or the Y axis, or frankly even draw one for you, and there's a reason for that, okay? Sometimes, believe it or not, it's easier to draw your own. Maybe a lot of the time it's easier to draw your own. Because notice, when I find the amplitude here, that's easy, it's 2. But when I find the period, 2 pi divided by the number in front of x, the pi cancels, and the period just comes out to be a whole number. So it might not make much sense for you to have an x-axis labeled in terms of pi. Okay, so I'm going to leave this up to you and let you just put the 2 wherever you want it. If your amplitude is 2, okay, that means you're going to go up to 2 and down to -2. Since this is a sine curve, we do go through the origin. Okay, we start and end on the x-axis. Halfway, we go through the x-axis again. We have our maximum halfway between the first 2 x-intercepts and our minimum halfway between the last 2 x-intercepts. Once we get these 5 dots, we just connect them into a nice, lovely, delightful curve. Okay? You can always pause the video if I'm going too fast for you, or rewind, or look at it again. Skip ahead. Okay, anything you need to do. So let's look at this one. Amplitude would be the absolute value of -5, which is +5. The period would be 2 pi divided by pi over 2, which is 2 pi times 2 over pi, which means that the pi's cancel and we get 4. Is there anything else you might write down? I would probably make myself a note that this flips, because that's an easy thing to forget. Okay? I'm going to draw my x and y axis, and I'm going to mark it. I know that I want to go up to 5 and down to -5. I know I want to end at 4. Okay? So actually, maybe we could even 1, 2, 3. Let's put our 4 right here. Okay? This is a cosine graph, so that means it starts at its amplitude, which is 5. However, it's been flipped, so we need to start down here at -5. We also are going to end at -5. Halfway between the beginning and the end is where we have our other extreme value, and then halfway between those two is where we have our x-intercepts. And then we want to draw a nice, smooth, curvy, upside-down cosine. Okay, connect our 5 important dots in a meaningful way that doesn't look like a V or a pointy anything. Okay? All right, 2 more examples. Y equals -2 sine pi over 3x. So our amplitude is 2, and our period is 2 pi divided by pi over 3. So I'm going to keep change flip, and I get 6. I'm going to draw my x and y axis. Is there anything else I maybe ought to write over there in my list? What do you think? A flip? You are so smart. That's exactly right. I'm going to make myself a note to flip this. Okay, so this is a sine graph, which goes through the origin, flipped or not. Okay. I don't know that that's even, is it? Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm sure that was bothering you like it was bothering me. Okay. So we're going to go through the origin. We're going to begin and end on the x-axis. Halfway, which would be 3, right? We go through the x-axis again. I didn't mark it, but that's okay. Okay, and then this one is flipped, which means we go down to -2 and then up to +2. And then I connect my 5 dots in a nice upside down squiggle that looks like a sine curve. Okay? All right, last one. If you haven't paused the video yet, this is your chance. Pause the video Okay, make sure that you and I are getting the same answers. Okay? Period is 2 pi divided by 4 pi over 3. Yikes. Don't forget to keep change flip. Pi's cancel. 2 goes into 4 2 times, and I get 3 halves. Okay? That's fun, right? Who doesn't love a good fraction? Everybody loves a good fraction. Okay? Kind of the beauty of being able to draw your own x-axis, because I can put 3 halves wherever I feel like putting 3 halves. And I can put positive 3 here, and I can put negative 3 here. Did I mess up again? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. No, look at that. Okay, so the amplitude is 3. This is a cosine graph, so we're going to start at 3, and we're going to also end at our maximum. Halfway, we would have our minimum. Halfway between the two extreme values is where we cross the x-axis. Okay, it's kind of a lazy graph, wasn't it? Let's see. Okay, and we drew a lovely right side up cosine. I hope this helps. If you still have questions about your quiz, come see me and we can go over it, but certainly watch this video before you come and ask me questions. Okay?